Today it is physics for class 11, laws of motion. Now I have taken two type of questions because today I am going to do force analysis, different type of force analysis in different types of motion. This is very important for class 11 to solve the problems. Different types of force analysis. Now here you see a stone is tied to a string and is rotated with a uniform speed in a vertical plane. Vertical plane, that means this is a vertical, this stone, and it is in a vertical plane. This is your vertical plane. So means your vertical plane. This is your vertical plane, and here the stone is tied to a string, and this is the stone in a vertical plane with a uniform speed in a vertical plane. If mass of the stone is m and length of the string is r, this is r, length of the string, it is r. So here length of the string is r, and the linear speed of the stone is v. Then the tension in the string when the stone is at its lowest position, this is the lowest position and this is the highest position. So here you see that here the tension in the string will be in the upward direction and your weight will be in downward direction. But at this point your tension will be also in this direction and the weight of the body will be also in this direction. So now here you see that this is the tension. So at the lowest position, since it is moving in a circular path, so your tension here in this here, your tension is greater than mg. So the net force that will be T minus mg, and this is the net force which is the centripetal force which keeps the stone to move in a circular path. So here your centripetal force mv square by r, this will be T minus mg. This is the centripetal force, this will be T minus mg at the lowest point, means say at A, and this is B, means at point A. At point A, your net force will be T minus mg, and this T minus mg will be your centripetal force. So here this will be your centripetal force, and at point B, your centripetal force will be mv square by r, it will be T plus mg. This will be the centripetal force at point B. The similar is the case when an aeroplane, similar will be the case when an aeroplane moves in a vertical circle. So at this point the weight of the body will be downward and the reaction will be upward. So here your centripetal force will be, R minus mg. But at this point at this point, at highest point, your weight will be in the downward direction and the reaction will be also in the downward direction. So at this point, your centripetal force mv square by r is equal to r plus mg. So these are the force analysis when a stone is moving in a circular path, and then the tension, that means the centripetal force at the lowest position, will be T minus mg, and the centripetal force at the highest position will be T plus mg. But you see here in this question, a thin circular loop of radius r rotates about its vertical diameter. A smallest bead on the wire remains at its lowest position. That means here a circular loop this of radius r rotates about its vertical diameter. It is rotating about a small bead on the wire. There is a small bead on the wire. Remains at its lowest position. That means the bead must always remain here. Will remain at the lowest position. That means the bead, this is a circular loop, a thin circular loop of radius r, and rotates about its vertical diameter. A small bead on the wire, this remains at its lowest position. So here the normal reaction of the bead will be in the upward direction, and say it is making an angle theta with the horizontal, and your weight of the body will be downward, the bead will be downward mg, and this is your normal reaction n, this will be n, and this weight of the body will be balanced here by, this is theta again, this is n cos theta. So weight of the body will be balanced here by n cos theta, but the normal reaction is of the bead will be in upward direction. So here you see that this normal reaction must be balanced by a force in an opposite direction. This must be balanced by a force in an opposite direction. This bead must be balanced by a force in an opposite direction. So this force is mv square by r, and this is called as centrifugal force. This is called as centrifugal force. Centrifugal force. Now you see this, the force analysis in different cases. Here a string is tied to a stone and it is rotating in a vertical circle. So here you see your centripetal force is in the inward direction, and again a plane, this is the case of an aeroplane. This is the case of an aeroplane. This is the case of an aeroplane. Here in aeroplane you can also see that the your centripetal force at the lowest point and the centripetal force at the upper point, at the highest point. Now here this is a thin circular loop which is moving with its radius is r, is rotating about its vertical diameter, and a small bead, there is a small bead on the wire. So this bead, what is the a small bead is bead on the wire remains at its lowest position. So at this position, so what is your force analysis? You see that the normal will be acting upward, the norm, that is the reaction force, will be acting upward, and the weight of the body will be downward. This weight of the body will be balanced by n cos theta, the component of the normal, and but this force must be balanced by a force. So to balance this force, it is mv square by r, which is the centrifugal force. Here that is centrifugal force. Here this is the centripetal force. Centripetal force. Centripetal force. Now you see the force analysis for different cases. You see the force analysis for different cases. Now, so today I have taken this topic, that is the force analysis in laws of motions, and this force analysis will help you to solve the problems. Similar is the case, that is here there are some interesting factors here. If your velocity is 0 before tension, now here you see one thing, that is there is an important factor when a string is rotating in this direction, in vertical circle. There is an important point here when the string is rotating in a vertical circle. Here you see that it's an important, the most important point here is that if the velocity is 0, if your velocity is 0 before t becomes 0, suppose if your velocity is 0 before t becomes 0, then the bob will swing, then the bob will oscillate, then this bob or the stone will oscillate. It will oscillate. See, this is an interesting factor. And if your t is 0, before v, if your t is 0 before v comes to 0, if your t is 0 before v comes to 0, then the stone will move away from the circle. Then it will move away from the circle. So this is an important, very interesting phenomena here. So here you see this is an interesting phenomenon, that is if v is 0 before t is 0, then your bob or the stone will oscillate, and if your t is 0 before v, then it will move away, the stone will move away from the circle. So here you see the different uh, force analysis. These are the force analysis. So today I am going to deal with only the force analysis, different force analysis in different situations. Now again you see a different case, that is bank of a road. This is the bank of a road, theta, and your car or the vehicle is rotating, there is a circular motion, bank of the road. So here you see your friction will act in this direction, and see the weight of the body, it will act in this direction, mg, and your reaction will be in this direction, r. So let us do the force analysis here. Here you see, what do you find here, that this is the body, your frictional force is in this direction, the weight of the body is in this direction, this is the angle theta, your reaction is in this direction r, and the component of r which balances the which balance the weight of the body is r cos theta, which balances the weight of the body is r cos theta. And here this is the vertical component, this is the horizontal component, which is r sin theta, r sin theta. Again you see this is also theta. Again you see this f cos theta, f cos theta, f cos theta. So f cos theta is horizontal component, f cos theta is in this direction. So here you see the centripetal force, that is mv square by r, centripetal force is provided by r sin theta plus f cos theta. See, this is the centripetal force which is provided r sin theta and f cos theta. This is provided by the centripetal force mv square by r, which makes the body to rotate in a bank road. So here you see the force analysis. I am dealing today with the force, only with the force analysis, and this is very important. This force analysis is very important for to solve the problems, to solve any types of problem. Here you see. Now again, if we take a slope here, a type of a inclined plane, now you are taking an inclined plane. Now this is an inclined plane. Inclined plane. What do you find in this inclined plane? If a body moving with some acceleration, it is sliding down with some acceleration. So here your weight, this is mg, will be always act vertically downward, and your normal reaction will be always perpendicular. Remember that the normal reaction at any time, your normal reaction will be perpendicular to the surface of contact. Your normal reaction will be always perpendicular to the surface of contact. So here your normal reaction will be perpendicular to the surface of contact. So here you see that again this is theta, so this is mg cos theta, mg cos theta. So your weight, this will be balanced by your reaction mg cos theta, and mg sin theta will act, this is the horizontal component, will act in this direction mg sin theta, and if there is a friction, the friction will act in the opposite direction. So see the force analysis, how it becomes when we analyze the force. So this is an bank road. This is the case of a bank road. This is the bank road. Bank road. This is the case of a bank road, and here this is the case of an inclined plane when an object is sliding in a downward direction with some acceleration a. So here you see the difference in the force analysis. Here your mg, this is all, but the normal reaction is always perpendicular to the contact surface. So here you see the reaction r cos theta, it balances the weight, r cos theta balances the weight, and here there is a force r sin theta, the horizontal component. Similarly, the horizontal component f is f cos theta. So your centripetal force is this r sin theta plus f cos theta. So remember, these are the very important point today I am dealing, which is very important for class 11 student, that is how to solve the problems, and these are the force analysis which you can say you must remember this, all this. So here you see the what has happened here, but in the inclined plane you see the reaction is balanced by m cos theta, and this m sine theta which will act in this direction, which will make the body to slide. And if there is a frictional force, it is in opposite direction. Since the acceleration is here, it is moving in downward direction, there is an acceleration. So this is the force analysis for an inclined plane. Now suppose now let us take another case. So here this is suppose this is an inclined plane, this is an inclined plane, this is an inclined plane, and here this is a body, and this whole inclined plane is moving in this direction A with some acceleration A. Now yes, you see this whole inclined plane is moving with some acceleration A. So here now you see the force analysis again. Here the weight of the body will act downward, that is mg. Your reaction will be always perpendicular to the surface, that is r. Your reaction force will be always perpendicular to the surface r. And now you see that this here, this is theta, so this is mg cos theta. This reaction will be balanced by this. Now again you see that, and this horizontal component, that will be mg sine theta. Now here the most important point here, that since the body is moving with some acceleration, so according to Newton's third law, there will be a force F is equal to ma. Since the body is moving in a forward direction, since here you see that the body is moving in the forward direction, there is an acceleration, so there is a force here. So when there is a force, there must be a reaction. So the reaction will be in horizontal direction, that is ma. Your reaction will be in the horizontal direction, that is ma. That will be ma. And here you will find that in the horizontal direction, and this is the weight of the body reaction. So you will find this here, that again a component of it, this will be also theta, and the component of it will be here, will be cos theta. See this. So you find the differences in all the force analysis. I think so you can find the differences in all the force analysis. So here, if the inclined plane is moving with some acceleration, so here you see the force analysis. Because the inclined plane is moving with some acceleration, so no doubt there will be a force according to Newton's second law. So when there is a force, there will be a reaction because of Newton's third law. So the reaction will be in opposite direction, and the mg cos theta, which will be balanced by mg sin theta, and your mg cos theta will be equal to the reaction. So these are the force analysis. I am telling you all the force analysis which possible for analysis in laws of motion. Possible force analysis in laws of motion. This is very important for board or for any competition, either it is NEET or JEE Mains or JEE Advanced. For any type of competition, this force analysis these are the basics. This is very important. And similarly your R, which is equal to mg cos theta, So this is for if this is if an inclined plane is in motion. Now again you see that there are suppose there are two blocks two blocks, say one is m1, another is m2. So they are moving with some acceleration a in this direction, So now moving, that means your force is acting in this direction f. So to find out the acceleration, we consider this whole body as a system. So to find out this acceleration, this will be f by m1 plus m2. This will be f by m1 plus m2. And the force exerted by m1 on m2, that the force exerted, F1 force, let this be F1 force, exerted by m1 on m2, that will be m1a, and the force exerted by m2 on m1, on n1, that will be m2a. Remember this. The force exerted by m1 on m2 will be m1a, and the force exerted by m2 on m1 will be m2a. Remember this. But when we calculate the acceleration, we consider this as a whole system. Similarly, it may be like this also. Suppose there are two or three blocks here, let this be m1, m2, m3, and the force exerted is f. Then your acceleration, for this acceleration, we consider this as a whole system. So your acceleration will be f, that is m1 plus m2 plus m3. This will be the acceleration. So if you find a tension here, so here your tension will be what? That means f minus t, that is the net force, will be m3 into acceleration. This will be the acceleration. So these are very important. So when the box, these are the different blocks, and they are or different body, they are connected by string. To find the acceleration, we consider this whole as a system. Similarly, to find the acceleration, this we consider the whole as a system. So here your acceleration will be f by m1 plus m2. Now remember that the force exerted by f1 on m2, that will be m1a, and the force exerted by f2 on mass m2 on m1 will be m2a. So, uh, there are also force analysis. Suppose you can take, suppose here this is a block, here. So here a force is applied F, so your reaction will be in opposite direction. So here weight, this is mg, and then your friction will be in this direction, F. So you find the different types of force analysis, and again it may be of something like this. Say something like this. Here this is a pulley, something like this. Say something like this. So here the body is moving with this acceleration here. So the acceleration in downward, the same acceleration will be upward. Remember, same acceleration will be upward. And here this is weight mg. So your tension will be T here, upward. And again here same thing, your this will be m1, and your weight will be m2 g downward, but your tension will be upward. Here you see, tension will be upward. Now again, let us take another situation. So here I have given you all type of force analysis. So these are very important, and this type, when the inclined plane is moving, then what will be the force analysis? When the two body is moving, what will be the how to force analysis? and if they are connected, then what will be the force analysis? And if it is a block is placed vertically on a wall, then what will be your force analysis? And if a string is moving downward, two weights are uh, at the two ends, then what will be your force analysis? I have given you different types of force analysis. Now there is one more analysis, that is, let me tell you. One more analysis, that is, suppose this is a string here, it is making some angle with the horizontal. Now at this point, what will be your force analysis? At this point, what will be your force analysis? So here you see that this is mg, and this bob is moving is moved in this direction, so your centripetal force will be in this direction. Let this be the r string. Your centripetal force will be in this direction, mv square by r. Your centripetal force will be in this direction, and the tension will be in this direction, T. So here you see that this will be theta, so T cos theta, this will be in upward direction, and your the horizontal direction, that is uh, T, that is T sine theta, this will be T sine theta. So no, 1 minute. Here there is a mistake here. Yes, 1 minute. The force analysis will be not in this direction. Here you see your force analysis. Uh, yeah. Your weight will be in this direction, mg. Your tension T will be in this direction. So here you see this will be theta. So your this will be mg cos theta. No doubt this body is moving in this direction, so your this will be your centripetal force mv square by r. This will be centripetal force. Here this length, string length is r, so this is theta. So mg, and your next your horizontal component, that will be mg sine theta. So here you see that the force analysis, suppose this is a type of pendulum, that means a bob which has moved to this position. So here you see that your weight acts downward, the tension will be always along the string, and the mg cos theta, which will balance the string. And now here one more thing, that is mg sine theta will be in this direction. So here you see that you see the figure here, perpendicular, this is mg sine theta. I shifted it more than 90 degrees. So now here you see that this will be also theta. So your mv square by r cos theta, this will be your force. So here you see the force analysis here, that is a bob, this is a bob. So it's a type of a simple pendulum. So here your weight will act downwards, the tension will be in this direction, the centripetal force, because it is moving in this direction, so your centripetal force will be in this direction. And now this tension will be balanced by the mg cos theta, and it's this perpendicular component, that is this the base, there's a perpendicular mg sine theta, and the same angle will be made by this theta, and this mv square by r cos theta. So this will balance this and t will balance this. So t will be equal to this and mv square r cos theta will be this. So see how the different types of force analysis I have shown you.